Welcome to Energy Northwest, where we've been busy producing clean energy for the Northwest for more than 60 years. Today, we'll get an in-depth look at how Energy Northwest is providing Washington State with clean energy right now, and how we're looking ahead to meet the needs of a growing Northwest economy and a carbon-free future. Energy Northwest is a public power agency founded by the Washington State Legislature in 1957. Our members include more than 24 public power utilities located across Washington. Energy Northwest is committed to providing our public power members and regional customers with safe, reliable, carbon-free power and energy solutions. Together, our members provide electricity to about 1.5 million people. Energy Northwest owns and operates a diverse mix of energy generating projects, including the Packwood Lake Hydroelectric Project, located in Lewis County, Washington, about 20 miles south of Mount Rainier. The 27-megawatt facility was Energy Northwest's first generation project and went into commercial operation in 1964. The Nine Canyon Wind Project, which includes 63 wind turbines in southeast Kennewick, Washington, can generate up to 96 megawatts of electricity. The White Bluff Solar Station, a small demonstration solar project near Richland, Washington, can produce about 38 kilowatts of direct current electricity. The Horn Rapids Solar Storage and Training Project near Richland, Washington, which is a 4-megawatt utility-scale solar project with a 1-megawatt battery storage component. Energy Northwest owns and operates the battery system, and the project also provides a training ground for solar and battery technicians. In addition, the Energy Services and Development Team also provides operations and maintenance services to several hydroelectric facilities in Washington and Oregon. The team also provides calibration, environmental and analytical services, as well as project management for energy solutions, like expanding electric vehicle charging stations across the state. And then there's Columbia Generating Station, Washington State's third largest electricity generating facility. Columbia Generating Station is the Northwest's only nuclear power plant. It's located about 10 miles north of Richland, Washington, and came online in 1984. Columbia is a boiling water reactor producing 1,207 megawatts of electricity around the clock. That's enough power for about 1 million homes or a city the size of Seattle. Nuclear is a baseload form of electricity, which means it's available all the time. In the U.S., nuclear energy provides about 20% of our electricity and 55% of our nation's carbon-free energy. Along with hydro, wind, solar, and battery storage, nuclear has a vital role in achieving our carbon-free energy future. Inside these buildings behind me is where nuclear fission is heating water into steam. That steam turns a turbine and generates electricity. So where does the energy come from? For fuel, we use pellets of uranium-235. Each pellet contains as much energy as nearly a ton of coal, 149 gallons of oil, or more than 17,000 cubic feet of natural gas. The pellets are stacked inside fuel rods and gathered into fuel bundles. The bundles are then inserted into fuel assemblies, which are about 15 feet long. 764 fuel assemblies and 185 control rods make up Columbia's reactor core. There are millions of these pellets in the reactor, and they're very energy dense and can generate tons of electricity that's all emissions free. In the control room, a team of exceptionally skilled reactor operators begin the fission process by slowly moving control rods out of the core, which starts a chain reaction. The heat produced by this reaction boils water within the reactor core and makes steam. The steam from the reactor vessel is channeled to turn 4 large turbines attached to a large generator, which turns 1,800 times each minute. As the steam leaves the turbines, it's cooled back into water in a heat exchanger called the condenser and returns to the reactor in a closed loop. The condenser is filled with thousands of small pipes flowing with cool water from the Columbia River. As the hot steam passes by the outside of these cool pipes, it's condensed back into water. Columbia operates on a closed-loop cooling system, drawing about 22 million gallons of water daily. To put that into perspective, about 35 to 50 million gallons of water flow past the intake structure every minute. The water inside the condenser pipes absorbs a lot of heat, so to cool it, we have 6 mechanical draft cooling towers. This is Tom. He works in our maintenance department as a program manager, where he's responsible for the foreign material program and ensuring Columbia is kept looking its best.
So each of these cooling towers behind me are 65 feet tall. They're 200 feet at the base, with 6 fans on top. The water from the condenser is pumped into them at 570 gallons per minute into large canals at the top of each cooling tower, where fans blow air across the water, causing the heat to evaporate into the atmosphere. The large plumes are going up into the air. Behind me is water vapor. At the bottom of the towers, the cool water is collected and pumped back to the condenser to be used again.
The reactor building stands 23 stories tall. Inside is the reactor vessel, which is 85 feet in diameter and 16 stories tall. The containment vessel has a thick steel wall surrounded by a wall of steel reinforced concrete that's more than 5 feet thick. Behind the reactor vessel is the turbine generator building, where the low and high pressure turbines are located and where the generator is producing the electricity. Lower sections of the building contain the main steam condenser system and other equipment to assist turbine operations. Each person who enters the radiologically controlled area must sign on to a work permit and have the proper qualifications and training. This is Shannon. She works in construction and project management, where she's responsible for managing capital projects at Columbia.
This is a diesel generator building where we have 3 diesel generators that are available for backup power. We also have a 4th mobile generator outside and a 5th stored nearby that would provide electrical power for critical loads in the unlikely event that other power systems were not available. Each diesel generator can activate within seconds and be fully loaded in less than 15 seconds.
Nuclear plants are built to withstand natural disasters and other emergencies. Each facility prepares a response plan with one goal in mind: protecting our communities and employees. Beth is a nuclear design engineer, where she provides technical analysis and designs in support of operations, systems, and programs at Columbia.
Once the steam passes through the main condenser and returns to water, it collects in the hot well and is picked up by condensate pumps and sent through a series of filters and demineralizers. These large pumps are part of the condensate feedwater system, which applies and preheats water to re-enter the reactor. They preheat the water from about 90 degrees to 450 degrees Fahrenheit. Once purified, the condensate booster pumps push the water to the feed water heaters and pumps that water back to the reactor vessel.
As a nuclear electrician, Drake is responsible for installation and maintenance on electrical equipment and systems at Columbia.
After the steam leaves the reactor vessel, a series of moisture separators purify the steam, and it gets channeled to 4 large turbines attached to the main generator, 1 high pressure turbine and 3 low pressure turbines, all attached to a single shaft. The main generator converts the mechanical energy of the turbine into electricity, producing about 1,207 megawatts electric. Just outside is our transformer yard, where the electricity goes to the main transformers and sent out to the electric grid.
This is Zach, one of Columbia's shift managers. He's responsible for assuring safe, efficient, and reliable operation of the plant.
Here in the control room, reactor operators monitor plant conditions. Operators authorize and coordinate surveillance and maintenance activities of systems and components that can affect reactor power and safety systems. Highly trained crews work in the control room for 5 weeks and then spend 1 week in the simulator participating in training and testing scenarios. The simulator is an exact replica of our control room. Operations crews prepare and test for the unlikely event of an emergency at the plant.
Columbia produces a tremendous amount of electricity from the nuclear fuel in its core, but like any fuel, eventually it starts to run out of energy and we have to replenish the supply. Every 2 years, typically in the spring, we shut down the reactor for an outage. To help conduct the work, more than 1,000 skilled workers hired locally and from across the country join Energy Northwest workforce to support refueling and maintenance projects. The work conducted during the outage ensures we maintain high levels of equipment reliability.
The outage is also an opportunity to perform maintenance and upgrades on other equipment that isn't accessible when the plant is operating. It's a busy time for everyone as we move through actions and activities that have been in the planning process for almost 2 years. Through planning and attention to detail, workers ensure the work is done safely and efficiently. This is vitally important so that Columbia can be brought back online to provide the region much needed electricity for another 2-year run.
During each outage, we remove the layers of shielding and various components of the reactor vessel and then flood the open cavity with water using detailed procedures. Operators replace about 1/3 of the fuel assemblies in Columbia's core with new fuel assemblies. Fuel that's been in the reactor core for 6 years is placed in a deep pool, which removes residual heat from the assemblies. The fuel assemblies in the deep hole will stay there under 20 feet of water for about 5 years before being moved to Columbia's on-site above-ground dry cask storage.
This is Miguel from Reactor Fuels. He's responsible for Columbia's nuclear fuel design and reactor core performance.
The fuel moved out of the reactor core during the outage is called used fuel. Every 5 to 6 years, we remove the used fuel that's been safely stored underwater into dry above-ground storage. The fuel is housed in large steel and concrete lined casks and then brought here to the independent spent fuel storage installation. All 45 casks of fuel from Columbia's operating history is stored here and will remain on site safely and securely until a national repository is built or until the recycling of used fuel becomes available in the United States.
The nuclear energy produced at Columbia has zero greenhouse gas emissions and provides firm electricity 24/7. This reliable electricity is what powers our communities, and it's vital to our future. To get to a 100% clean energy future, we need renewables and storage and existing nuclear like Columbia. But to meet growing electricity demands, we also need new sources of reliable, affordable, and emissions-free electricity. Advances in nuclear technology hold the promise of achieving a clean energy future, and Energy Northwest is at the center of it. For that, we'll head to the Morrison Energy Center, where we'll talk to Greg, Vice President for Energy Services and Development.
Energy Northwest's mission is, and always has been, to provide electricity and energy solutions for our public power customers in the region. Across the country, the focus is on reducing carbon emissions and minimizing the impacts to our environment. And we are proud that our generation portfolio is 100% clean, with hydro, wind, solar, battery storage, and of course, nuclear. We're also looking at solutions in the transportation sector to reduce greenhouse gas emissions. And Energy Northwest is working with utilities across the state to build out electric vehicle charging station infrastructure. As Washington State implements the Clean Energy Transformation Act to reach 100% clean energy by 2045, and as we move away from fossil fuels, there's a real concern about resource adequacy and the ability to meet the peak demands for power. Energy Northwest feels uniquely positioned to help our state meet those clean energy goals. And we believe in having a clean technology solution that includes Columbia Generating Station, new and existing renewables, and state-of-the-art advanced reactor technologies. We're very excited to be partnering with two technology companies, X-Energy and TerraPower, which were both awarded federal funding under the Department of Energy's Advanced Reactor Demonstration Program to support the design, license, and construction of advanced reactors. We believe nuclear energy has a key role to play alongside renewables now and well into the future.
Energy Northwest is proud to provide our public power members with safe, reliable, and cost-effective power generation and energy solutions. And at the heart of this mission is the people who work here, from reactor operators to engineers, chemists to craft workers, computer analysts to security officers. Each of us have a role, through sustained excellence in performance and innovation, to power our clean energy future.